Now I am taking one more problem. Solve the equation tan inverse 1 minus x upon 1 plus x equal to 1 upon 2 tan inverse x. X plus tan inverse. This is the trigonometric equation in which question we want to find the value of x. Now we start. Tan inverse 1 minus x upon 1 plus x equal to 1 upon 2 tan inverse x. Since tan inverse a minus b upon 1 plus ab equal to tan inverse a minus tan inverse b. So now left hand side can be reduced. Tan inverse 1 minus x upon 1 plus 1 into x, this can be written in the form is equal to again 1 upon 2 tan inverse x. Now apply this identity. So we have tan inverse 1 minus tan inverse x. Here 1 at the place of a and x at the place of b is equal to 1 upon 2 tan inverse x. This tan inverse 1 can be written as tan inverse tan pi by 4. This tan inverse can be transferred, so this becomes 1 upon 2 tan inverse x plus tan inverse x. So now pi upon 4 equal to 3 by 2, 1 by 2 and 1, 3 by 2 tan inverse x. This implies that tan inverse x equal to 2 pi upon 12, that means pi upon 6. So x equal to tan pi by 6. This implies that x equal to 1 upon 8. So this is the solution of this trigonometric equation. Now I am taking one more problem from the chapter inverse trigonometric function. Solve the equation for x sin inverse 1 minus x minus 2 sin inverse x equal to pi by 2. The equation is sin inverse 1 minus x minus 2 sin inverse x equal to pi by 2. This can be written as sin inverse 1 minus x equal to pi by 2 plus 2 sin inverse x. This can be written as 1 minus x equal to sin pi upon 2 plus 2 sin inverse x. So this is 1 minus x equal to cos 2 sin inverse x, because sin pi by 2 plus theta equal to cos theta. So sin pi by 2, assume as theta here, sin pi by 2 plus theta become cos theta. Put, now take a substitution, sin inverse x. Sin inverse x equal to theta, that means x equal to sin theta. Now 1 minus sin theta equal to cos 2 theta. Sin inverse x replaced by theta and x replaced by sin theta. Now this can be written as 1 minus sin theta equal to 1 minus 2 sin square theta. Use the identity cos 2a equal to 1 minus 2 sin square. Now 2 sin square theta minus sin theta equal to 0. Now take common sin theta here. We have 2 sin theta minus 1 equal to 0. So there are two options. Sin theta equal to 0, sin theta equal to half. That means and the sin theta is the place of x. So x equal to 0 or x equal to half. But x equal to half not satisfy the equation first. So only solution x equal to 0. Here if we put x equal to 0, then we have sin inverse 1, that means pi by 2. Sin inverse 0 becomes 0, so pi by 2 equal to pi by 2. This value x equal to 0 satisfies this equation, but if we have x equal to 1 by 2, so this becomes sin inverse 1 minus 1 by 2, that means sin inverse 1 by 2, that is pi by 6, and this becomes 2 sin inverse 1 by 2, that means minus pi by 3. So here is minus pi by 6, here is pi by 2, so we have shows that this value is not satisfy the equation. This is not the solution of this equation. So only solution is that x equal to 0. So x equal to 0 is that. Now one more problem from inverse trigonometric functions. Prove that cos tan inverse sin cot inverse x equal to under root 1 plus x square upon 2 plus x square. This is a question from the IIT JEE entrance examination. So now we start with left hand side. Cos tan inverse sin cot inverse x. Now we use the triangle method for this type of questions. Cot inverse x, that means base upon perpendicular. So use the Pythagoras theorem. We have 1 plus x square. This is for cot inverse x. Now cos tan inverse sin, and this cot inverse x now can be written sin inverse perpendicular upon hypotenuse. So 1 upon square root of 1 plus x square. So now next step become cos tan inverse. Now this is elimination, self adjustment. So we have only 1 upon under root 1 plus x square. And now we start with tan inverse. So now next diagram shows that for tan inverse x. So this is perpendicular and this is base under root 1 plus x square here. Tan inverse perpendicular upon base. Now use the Pythagoras theorem. So a is a perpendicular square plus base square, so this become 2 plus x square now. So in next step this become cos, and now this tan inverse convert into cos inverse. So cos inverse base upon hypotenuse, that means under root of 1 plus x square upon under root of 2 plus x square. This implies that 1 plus x square 2 plus x square. This is the right hand side. So if we use the figure method, this type of question will be easy in solving. Now see one more question from NCERT book. We want to find the value of tan inverse x upon y minus tan inverse x minus y upon. That means we want to evaluate this. So now next step become tan inverse x upon y minus tan inverse x minus y upon x plus y. Now tan inverse x minus y upon x plus y. Next step, tan inverse x upon y minus tan inverse x upon y minus 1 upon x upon y plus 1 divided by y. Here x upon y minus 1, x upon y plus 1, numerator and denominator. Now this can be arranged. Tan inverse x upon y minus tan inverse x upon y minus 1 upon 1 plus 1 into x upon y. This denominator can be arranged 1 plus 1 into x upon y. So now next step, tan inverse x upon y minus, this is tan inverse a minus b upon 1 plus ab. So tan inverse a minus tan inverse b. Here we use the identity tan inverse m minus n upon 1 plus mn equal to tan inverse m minus tan inverse n. Now tan inverse x upon y minus tan inverse x upon y plus tan inverse 1 cancel out, tan inverse tan 1 tan pi by 4. So this becomes 5. Now next problem is from your CBSE examination 2014, not a part of your NCERT book, but is a question of CBSE board examination. Cos inverse x plus cos inverse x upon 2 plus under root of 3 minus 3x square upon 2 equal to pi by 3. So we start with left hand side. Cos inverse x plus cos inverse x upon 2 plus under root 3 minus 3x square upon 2. Now next step become cos inverse x plus cos inverse 1 upon 2 into x plus root 3 upon 2 under root 1 minus x square. Let x equal to cos theta, 1 upon 2 equal to cos alpha. So this become cos inverse x plus cos inverse cos theta cos alpha plus pi by 3. Sorry, not alpha. We take a value of pi by 3. Cos theta cos pi by 3 plus this is the value of sin pi by 3 and this become 1 minus cos square theta. So now next step can be written as cos inverse x plus cos inverse. This is cos theta cos pi by 3 plus sin theta sin pi by 3. Cos theta cos pi by 3 plus sin theta sin pi by 3. Now This become cos inverse x plus cos inverse cos theta pi by 3 minus theta. This become cos inverse x plus pi by 3 minus theta. This become cos inverse x plus pi by 3 minus cos inverse x, because x equal to cos theta here. So we have only pi by 3. This is our right hand side here, pi by 3. Now one more question from NCERT, out of NCERT, but this is a question from your CBSE board examination 2016. If cos inverse x upon a plus cos inverse y upon b equal to alpha, then prove that x square upon a square minus 2xy upon ab cos alpha plus y square upon b square equal to sin square alpha. And sometimes the value a and b can be replaced by the numerical values. So we start the question. Since this is given cos inverse x upon a plus cos inverse y upon b equal to alpha. Apply the identity of cos inverse. So we have cos inverse x upon a into y upon b minus square root of 1 minus x square upon a square 1 minus y square upon b square equal to alpha. So now we have the identity cos inverse x plus cos inverse y equal to here cos inverse x plus cos inverse y equal to cos inverse xy minus 1 minus x square 1 minus y square. This is the identity used there. Now x y upon ab minus square root 1 minus x square upon a square square root 1 minus y square upon b square equal to cos alpha. This become cos alpha. Now this can be written as xy upon ab minus cos alpha equal to square root of 1 minus x square upon a square under root 1 minus y square upon b square. Squaring. So we have xy upon ab minus cos alpha whole square equal to 1 minus x square upon a square 1 minus y square. Ignore the direct, open the whole square. First we take the whole square, again next step we open the bracket. So this will become x square y square upon a square b square plus cos square alpha minus 2xy upon ab cos alpha equal to 1 minus y square upon b square minus x square upon a square plus x square y square upon a square b square. Open the brackets here. So we have this value is cancelled out by this value. Transfer the term, both the terms here in left hand side, x square upon a square y square upon b square minus 2xy upon ab cos alpha equal to 1 minus cos square alpha. So finally we have x square upon a square minus 2xy upon AB cos alpha plus y square upon b square, and 1 minus cos square alpha become sin square.